Okay, so what we're going to do here is we're going to look at the ratio of, this is the radius of Mars to the radius of the Earth.
All right.
It's about 1.5324. The radius of Mars' orbit, I mean, to the radius of Earth's orbit. Again, we're just pretending that they're circles. This is the Mars time to orbit divided by Earth's time to orbit. So I'm going to approximate this as 1.8809. See that?
Okay. Yeah.
And now, because I don't like the these decimals, I'm going to use continued fractions to approximate them. So at first I'm using 3 continued fractions to approximate them.
Okay.
3 levels of the continued fraction. And you can probably see on the screen that it says it's 15/8 and 3/2.
Yeah.
Approximately.
Approximately. But then what I'm going to do is I'm going to take the middle point of the orbit, although I'm not dividing by 2, but basically taking the middle of Earth and Mars. So as Mars goes around the sun, it makes a circle, we're pretending, and the Earth makes a circle. And
we're looking at the distance, the middle of the distance between them.
The middle, if we drew a line between them and we're looking at the middle point, what that looks like.
Right.
Okay. And you don't have to worry about the cosines and sines, but you're studying cosine and sine now. So when I do a parametric plot that's just, I'll do it down here, hopefully it's on screen. Cosine t, sine t. So the x-coordinate's cosine, the y-coordinate's sine.
This is a circle.
This is going to be a circle. 0 to, let's go to 6 pi. This makes a circle. Okay, is that on the screen? Sort of. There's our circle. So that's what I'm saying the Earth is doing. Cosine and sine. And then I have to get the average, I have to add in the other point and divide by 2. I'm just not dividing by 2 because I'm scaling it. So B is the ratio of the distance from the Mars radius to Earth's radius. So it's about 1.523. I think it's 1.5234. I think that's a typo. 1.5234 away. About 1.5 times away. You can see the first approximation used here is 3/2.
Yeah.
So that would make a larger circle, and it takes about 1.8 times as long. So I have to divide the time by 1.8. Okay?
Alright.
So what do you think this is going to look like? What do you think the midpoint of Earth to Mars is going to look like as these planets are going around the sun?
Well,
it's gonna shrink and grow. So it's gonna get large. It's gonna get larger and then get smaller again. And might.
so are we starting here where they're just diametrically, like there's the radius of Earth, radius of Mars, they're on the same radius from the center of those 2 circles?
Yep. Kind of right next to each other is where we're starting.
It'll start small, it'll get big, and then it'll get small again as Earth and Mars come around to be close to each other again, but it won't be linear like this circle.
Okay.
It'll like start off getting farther away, small, and then faster and faster, and then getting closer, slower, and then faster and faster, I think.
Here's what it looks like.
Whoa.
It's pretty interesting. What actually is very symmetrical.
And weird symmetry, it's 7-fold symmetry.
Right, now this is just an approximation, by the way. This is just using the first 3 parts of the continued fraction.
Mm-hmm.
But this is an approximation to what the sort of middle point between Earth and Mars looks like. So why is it sometimes very close?
Well, when they're on the same radial line from the center,
Okay.
they'd be really close.
All right, why is it sometimes really, so when it's close, it's like here. Why is it sometimes really far away?
Well, sometimes you might be like, the distance might go actually through the sun.
Yeah.
So that would be really far away.
And if I make a better approximation, if I go to, say, I use the first 4 pieces of the continued fraction,
Yeah.
what do you think it's going to look like?
Maybe more loops in here. And
No.
more symmetry. There's more like teardrop shapes.
Yeah. Pretty cool, huh?
Yeah.
So that's this is this sort of math. So there's a little bit of trigonometry studying this, and in here we're still, by the way, approximating the orbits with circles. So in fact, if you did this properly and wrote the orbits as ellipses, you'd even have a different shape. But it's pretty cool, and this is the sort of ideas that you have to make and study, the mathematical ideas that you have to study when you're trying to figure out how to get a rocket
To Mars.
to Mars.
Pretty neat.
Yeah, it's really cool. Do you guys have any other questions?
No.
No.
All right, so your homework assignment is to go build a rocket and then go to Mars.
Cool.
All right, good job, guys.